Welcome to PreMath. In this video, we have got this blue semicircle along with this yellow circle fully inscribed in a rectangle ABCD, as you can see in this diagram, such that this blue semicircle is tangent to this yellow circle at this point T. And furthermore, the area of this blue semicircle is 2 pi centimeter square. And now we are going to calculate the area of this tiny yellow circle. Please don't forget to give a thumbs up and subscribe. Please keep in your mind that this figure may not be 100% true to the scale. Let's go ahead and get started with the solution. And here's our very first step. Let's focus on this blue semicircle. And now we know that the area of this blue semicircle is 2 pi centimeter square. So the area of the full circle is going to be 4 times pi. And now let's go ahead and tweak this 4. 4 could be written as 2 square. So therefore the area of this whole square could be written as pi times 2 whole square centimeter square. And now let's recall the area of a circle formula. Area equals to pi r square, where r is the radius. So if we compare this formula with this one, we can see that this 2 is going to be our radius of this blue semicircle. Now let's assume the radius of this blue semicircle is represented by this uppercase R. So therefore our this uppercase R value turns out to be 2 centimeter. And here's our next step. Let's go ahead and connect these points A and this point O. And now we are interested in finding this distance AO. And now let me go over this crucial factor. These centers O and P along with this point of tangency, they are collinear. That means they lie on the very same line. Now let's go ahead and connect these points P and F. And now we can see that this PF is the radius of this yellow circle. Let me call this radius as lowercase r. And now let's recall this circle theorem. According to this theorem, the angle between the radius and the tangent line will always be 90 degrees, as you can see in this diagram. Therefore, in our case, this angle is going to be 90 degrees since this is our radius and this is our tangent line. Now we can see that this EP is also the radius of this yellow circle. If this is our radius R, then this AF is going to be our radius R as well. And now let's focus on this tiny right triangle AFP. And now let's go ahead and apply the Pythagorean theorem. And here's our Pythagorean theorem: a square plus b square equal to c square. So let me go ahead and call this side A, this side B, and our longest leg side C. Let's go ahead and fill in the blanks in this Pythagorean formula. A in our case is R, so r square plus r square equal to c in our case is AP whole square. Let's go ahead and simplify. So our AP whole square turns out to be 2r square. Let's go ahead and undo this square by taking the square root on both sides. On the left hand side, this square and square root is gone. So our AP length turns out to be this square and square root is gone. So that's going to be r times square root of 2. So therefore our this distance AP turns out to be r times square root of 2. Let's go ahead and make an observation. We know that this OT is the radius of this blue semicircle, and we know the radius, this one, is 2 centimeter. Now let's focus on this PT distance. This is the radius of this yellow circle. Let me call this one our radius lowercase r. Therefore, this whole distance AO is going to be the sum of 2 plus this lowercase r plus this AP distance, which is r times square root of 2. So therefore, our distance O A is going to be 2 plus r times the square root of 2. Let me go ahead and call this our equation number 1. And here's our next step. Let's go ahead and connect these points O and Q. And now let's recall this circle theorem once again. The angle between the radius and the tangent line will always be 90 degrees. So no wonder this angle has got to be 90 degrees. And as a result, we get this right triangle AQO. And now we can see that this OQ is the radius of this blue semicircle. And we know the radius is 2. So therefore, this side is 2 centimeter, and we know that this OD is the radius of this semicircle as well. This is 2 units. So therefore, this distance AQ is going to be 2 centimeter as well. Now let's go ahead and apply the Pythagorean theorem on this triangle AQO. And here's our Pythagorean theorem once again. A square plus b square equal to c square. Let me go ahead and call this side A, this side B, and we are going to figure out this side OA. I'm going to call this side C. So let's go ahead and fill in the blanks in this Pythagorean formula. A in our case is 2, so this becomes 2 square plus 2 square again equal to OA whole square. Let's go ahead and simplify. 2 square is 4 and 4 again. So if we add these one, we got OA square turns out to be 8. Let's go ahead and take the square root on both sides to undo this square. So this square and square root is gone. So our OA value turns out to be equal to, and we know that the square root of 8 could be simplified to 2 times the square root of 2. So therefore I can write this thing 2 times the square root of 2. Let me go ahead and call this as our equation number 2. And here's our next step. Let's go ahead and compare these equations 1 and 2. We can see the left hand sides are same. So therefore we can equate the right hand sides as well. So therefore I can write 2 plus r times square root 2 equals to, on the right hand side, 2 times square root of 2. Now let's go ahead and move this 2 on the right hand side, and here we can see r is in common. So therefore I can factor out r. So we got square root of 2 plus 1, and on the right hand side 2 is in common. I can factor that one out. So we got square root of 2 minus 1. And now let's go ahead and divide both sides by square root of 2 plus 1. This is gone. So therefore our radius lowercase r turns out to be 2 times square root of 2 minus 1 divided by square root of 2 plus 1. And now we can see we got a radical at the denominator. Therefore we are going to rationalize the denominator by multiplying and dividing by its conjugate, which is square root 2 minus 1 divided by square root of 2 minus 1 as well. So therefore our this lowercase r is going to be on the top. Numerator could be written as 2 times square root of 2 minus 1 whole square divided by this square root of 2 plus 1 times the square root of 2 minus 1. And now let's focus on this part on the numerator. And here I have copied it down. And now let's recall this famous identity. A minus b whole square could be written as a square minus 2ab plus b square. We are going to apply it on this one. And if we simplify this one, this square of square root of 2 turns out to be 2. And this 1 square is same as 1. And if we simplify everything, this turns out to be 3 minus 2 times square root of 2. So therefore this whole numerator part, this one, I'm going to replace with this one. So therefore our lowercase r turns out to be 2 times 3 minus 2 times square root of 2 all over. And now let's focus on this denominator. And here I have copied it down. And now let's recall this another famous identity. A plus b times a minus b could be written as a square minus b square. We are going to apply it over here. So therefore this could be written as square root of 2 whole square minus 1 square. And now if we simplify this thing, that is going to give us 1. So therefore the denominator part, I'm going to replace it by 1. So let me write down 1 in the denominator. And this is the radius of the yellow circle. And now here's our final step. Let's go ahead and calculate the area of this yellow circle, whose radius has been figured out in our previous step. And now let's recall the area of a circle formula once again. Area equals to pi r square. So therefore the area of this yellow circle is going to be pi times r. In our case is this one. Let me go ahead and write it down. 2 times 3 minus 2 times square root of 2 whole square. And now we know that this 2 square is going to give us 4. So therefore this thing could be written as 4 pi times 3 minus 2 times square root of 2 whole square. Now let's recall this identity once again. A minus b whole square could be written as a square minus 2ab plus b square. I'm going to apply it on this part. And here I have copied down this whole thing right here. And I took the square, and as you can see, this whole thing has been simplified to 17 minus 12 times square root of 2. So therefore I'm going to replace this whole part by this simplified form, 17 minus 12 times square root of 2. So therefore let's go ahead and write down 4 pi times 17 minus 12 times square root of 2. Let's go ahead and distribute this 4 over here. So thus the area of this yellow circle turns out to be 68 minus 48 times the square root of 2 times pi centimeter square, and that is approximately equal to 0.37 centimeter square. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.